Welcome to a new realm of the world of mathematics, known as the imaginary realm. In this realm, we're going to deal with imaginary numbers and complex numbers. Until this point, all of your math teachers have taught you that you can't take the square root of a negative number, right? Whenever you squared a negative number, you got a positive number. For example, when you squared negative 1 times negative 1, you got positive 1. Negative 2 times negative 2 gave you 4, and negative 3 squared gave you positive 9. Those are just a few examples. And the inverse of squaring a number was taking a square root. So logically, we can't take the square root of a negative number. Until now. Mathematicians were not happy about these limitations, so they created a complex number system. And they used the letter I to represent what we call imaginary numbers. By using this imaginary number I, we can now take the square root of a negative 1. And by being able to take the square root of a negative 1, we can take that factor of negative 1 out of any negative number, and this allows us to then take the square root of a negative number. And I'm going to show you how it works. Keep in mind throughout this process that any time you see the square root of negative 1, the answer will equal I. So if you see an I, you're seeing the square root of negative 1, or if you see the square root of negative 1, you're seeing I. Now how do we use that in our calculation? How do we use I equal to the square root of negative 1? Let's take a look at the square root of negative 16. Until now we couldn't do that. But let's see how we do. Negative 16 is actually the factors positive 16 and negative 1. We can break those up into two problems. So here we have it, we can break it up into positive 16 times negative 1. We now have the power to take the square root of both of those values. The square root of positive 16 is 4, and we know that the square root of negative 1 is I. So what we have is 4 times I, and we write that as 4I. So the square root of negative 16 is 4I. What was once unable to be done in our minds is now 4I. We can take the square root of a negative number. Let's try another one. The square root of negative 81. Again, let's break it apart into the product of two factors, a positive factor and a negative factor. Any negative number can have this done. You just take out the factor of negative 1. Square root of 81 is 9. And the square root of negative 1 is I, always. So the square root of 81, as I said, is 9. The square root of negative 1 is I. So the result is 9I. It's pretty simple. Let's try another one. In this case, the square root of negative 45, we have 45, which is not a perfect square, such as 16 and 81. But that's still not a problem, because we know how to simplify non-perfect squares. We just find the largest perfect square that will divide evenly into our non-perfect square. So we think to our list of perfect squares. And the largest value that I can think of that will divide evenly into 45 is 9. So I split apart 45 times 5. And I use my factor of square root negative 1. So now I have the square root of 9 times the square root of 5 and the square root of negative 1. I can now take the square root of negative 9, which is 3. I don't need to take the square root of 5 because it's not a perfect square. And I recall that the square root of I, or square root of negative 1, is I. And I can rewrite that now. Square root of 9 is 3. Square root of negative 1 became I. And my final answer is 3I times the square root of 5. Let's try one more. The square root of negative 200. Again, break it apart into a positive and a negative factor. The square root of 200 can be broken apart into the perfect square root of 100, because 100 is a perfect square. So the square root of 100 times the square root of 2 times the square root of negative 1. The square root of 100 is 10. 10 times 10 is 100. The square root of negative 1, again, is I. So I have 10I times the square root of 2. And I've managed to take the square root of another negative number. You try a few. Take the square root of negative 5, the square root of negative 7, and the square root of negative 99. Let me caution you on this problem. There's a negative out in front. I think you'll know what to do with that. Pause the video. Give these a try, and then restart and see if you get the same answer that I do. Okay, let's see how you did. When you took the square root of negative 5, I hope that you broke it up into a positive and a negative factor. Square root of negative 1 times the square root of 5. We can't take a square root of 5, so all we could do was take the square root of negative 1, which was I. So it's I times the square root of 5. When we took the square root of negative 7, there's a negative 1 sitting out here, and that just carried along. Break up the negative 7 into a square root of negative 1 times the square root of 7. The square root of negative 1 is I, times that negative 1 that's sitting out there, gave you a negative I times the square root of 7. And the square root of negative 99. Again, break it up into a negative 1 times 99. The square root of negative 1 becomes I. And I can break up 99 into the square root of 9 times the square root of 11. Square root of 9 is a perfect square, and it became 3. And I'm left with the square root of 11 under my radical. So now you've learned how to take the square root of a negative number using the imaginary number I. It's fairly simple. So let's see what other cool tricks we can do with the imaginary number I. When I is raised to exponents of the powers 1 through 4, there's a pattern that they follow. And if we memorize those first 4 powers, we can do some pretty quick calculations. Anytime I is raised to the power of 1, the answer is equal to I. I squared is always negative 1. And that's the one that you really need to have memorized, because that's the one you're going to see the most. I cubed is equal to negative I, and I to the 4th is equal to 1. Those powers and results will repeat in groups of 4. So just remember, I to the 1 is I squared is negative 1, that one being the most important. I cubed is negative I, and I to the 4th equals 1. If you can remember that pattern, then you're good to go. To use the pattern to calculate the powers of I, we can divide our exponents and observe the remainder to determine the answer. And here's the pattern that they'll follow. If there's no remainder, the answer will be 1. If there's a remainder of 1, then the answer will be I. If there's a remainder of 2, the answer will be negative 1. If there's a remainder of 3, the answer is negative I. And I'm going to show you how that works. Here's an example. Find I to the 23rd power. Well, I don't expect you to multiply I out 23 times. Let's use the power rules and exponents rules to see how that works out. So recall, to determine our answer, we divide our exponent by 4 and see what the remainder is. So let's divide our exponent by 4. So 23 divided by 4 is 5. 4 goes into 23 5 times, so that gets us to 20. We're almost to 23. How many are left over? Our remainder here is 3. So if we have a remainder of 3, according to our rules, the answer will be negative I. So that's how we use our pattern. Let's find I to the 2006. Do we really want to multiply it out 2006 times? I don't think so. Let's use the pattern. Let's take 2006 and see how many times 4 goes into that exponent and see how close we get. 4 goes into 2006 501 times. So that gets us up to 2004. So what's our remainder? 2006 minus 2004 leaves us a remainder of 2. So when we have a remainder of 2, the answer is negative 1. Let's try the next one. I to the 37. Let's divide 37 by 4. 4 goes into 37 9 times. Well, when I multiply 9 times 4, I get 36. So I'm not quite to 37. I have a remainder of 1. When the remainder is 1, the answer is I. Let's try one more. $8.28 divided by 4 equals 207. In this case, there's no remainder. So when the remainder is 0, the answer is 1. And that's how we use the remainder pattern to determine large exponents of I. We also have what are known as complex numbers. Complex numbers are when we combine real numbers with imaginary numbers. They have two parts. They have real parts and imaginary parts. We can't combine them completely into one number. They are just held together by sums. So they have two distinct parts, as I said. They have a real part and an imaginary part. To add or subtract complex numbers, you add or subtract the real parts with real parts, and add or subtract imaginary parts with imaginary parts. You write the results in correct complex form, which is A plus BI. Here are some examples. 6I plus 9I. That is just the combination of two imaginary numbers. There is no real part to that one. Or the real part would be 0. So 6I plus 9I would just be 15I. In the next example, we have the complex number negative 5 plus 6I plus the complex number 2 minus 13I. Our real parts are negative 5 and 2. So we combine those parts. So negative 5 plus 2 gives us negative 3. That's our real part. Our imaginary part is positive 6i and negative 13i. So when we put the 6i together with the negative 13i, that gives us a negative 7i as our imaginary part. When we put that back together into correct complex form, we have the complex number negative 3 minus 7i. In this last example, we need to distribute the negative number that is in front of the second complex number. This is a negative 1 and needs to be distributed through, so it's going to change the sign of the second complex number. So we're going to have 2 plus 3i minus 7 minus 2i. So combining our real parts, we have 2 and negative 7, which gives us negative 5. Our imaginary parts are a positive 3 and negative 2, which is a positive 1i. So that gives us the complex number negative 5 plus I. You try these. See how you do. Remember, in the second example, you have a negative 1 here to distribute. Pause the video and see how you do. Okay, let's see how you did. Locating your real and imaginary parts is the first part. So in the first example, the real parts are 5 plus 3. 5 and 3 come out of the two complex numbers. The imaginary parts, be sure to carry your signs, negative 2i and positive 3i. When you combine those, you should have 2 plus I, negative 2i plus 3i. There's your new complex number. In the second example, we have 2 minus 12, so we're going to have a negative 10 as our real part. And remember, you've got to distribute this negative 1, so it becomes a plus 1i. So we have negative 10 plus 7i. There's your new complex number. So to summarize, we now know about I, which lets us take the square root of a negative number by splitting up that negative number into a positive factor and a negative 1, because the square root of any negative 1 is just I. We can combine real numbers and complex numbers into special numbers called complex numbers. Write complex numbers in the specific order a plus bi. This should say imaginary numbers. I just realized I have a typo there. And when combining complex numbers, combine real parts with real parts and imaginary parts with imaginary parts.